Hello, good afternoon. In this section, I will present part of my research at Seoul National University about the Core Percolation's hyperbolic embedding of functional brain network, XDXD. So first of all, I'll try to introduce myself. My name is Reza Kocharaka. I'm currently working at Seoul National University Hospital about the Department of Nuclear Medicine. So the agenda of this today that I'll try to express the risk purpose, processing, the methods, results, and also the novelty of my research. First of all, about the research purpose, that the most real-world networks geometry plays an important role in the organizing the network. That's why in the study, I tried to figure out the global characteristic of the functional brain network. And it was expected that the hyperbolic geometry underlies the network. So it was demanded that the binarized network has a scale-free degree distribution. And for this purpose, I tried to find the correlation study, the time series of the asset fMRI. And the signals was the convoluted and the correlation coefficients were binarized by adopting a specific correlation value. So this is the concept. First, from the fMRI data, find the anatomic percolations with the time series correlation using the binary adjusted network, get the thresholding value, find the degree distribution, and embedding procedure using the PCOM, and the characteristic by the distance metric. We have the general characteristic applications to clinical data, which is the brain data set, and also reproducibility of the analysis. So this is the degree distribution. The degree distribution from the brain data, I tried to using the embedded network, which is the hyperbolic, spherical, and Euclidean components. So these figures represent about the hyperbolic, the x square, space s square in an Euclidean plane with the C1. So its component space has content curvature, which is the degree will be get the value -1 to +1 and 0 respectively. So this is the Core Percolation. For example, use the whole of the K value using the until the K1, K2 until K3, until the K240. So every main of the K will be provide the different accuracy. So this is the abnormality detection. So this one, the data set from the brain data set. So find the distance matrix of the voxel with the matrix edges wise comparison. So the data processing because the data are quite high dimensional with the 5,000 voxel and also 1,200 volumes. So the times for data processing is quite important with the PCOM. So we compute the probability of the connections determined. So the main outcomes, I can make the classification toward the type of the disease by using the PCOM, embedding functional brain every subject patient. So for example, this one for the 46 patient, for the 52 patients, for 55 and until 61 patient. So the quality of embedding, I try to compare the absolute value with the correlations absolute with the comparison of the connections probability by hyperbolic distance like this. And the main outcomes and make the spatial pattern of the disease of the brain voxel with the K50 until the K240, the maximum. So you can see there's a different type of the spatial brain, which is the DMN as the best feature to predict the disease in the brain. And also the novelty. The novelty that I do in the Seoul National University, I aim to investigate the geometric structure of the functional brain network by embedding the network into the hyperbolic space. For example, this one for the patient 1, patient 2, and until patient 3. So I can prove that the degree distributions of the network is scale-free. So furthermore, I can embed the network into the various product manifold and apply the better fidelity measures in hyperbolic spaces by comparing with the Euclidean ones. So that's what my research novelty at the Seoul National University. So I hope you enjoy this presentation. If you want to know more detail about this research, you can reach me at my Instagram at @karasaizer or send me by email to rezi.eco@ui.ac.id or rezi94@snu.ac.kr. So you can also visit my website like this. I said, thank you so much, and I will see you in next presentation.